Hey everyone, Mr. Voikin here. We're on Unit 8, Lesson 2, and we're going to be taking a look at the distance formula. Continue on from where we left off last time, looking at horizontal and vertical lines and using the coordinates to calculate the length of that line. So it says right here we've got a diagonal line, and in this case we're going to have to use Pythagorean's theorem to calculate the length of AB. And they're saying that AB is 15 units, and we just want to prove that. Now, just a little aside here for you. If you have a right angle triangle that is 15 on the hypotenuse, that means that on one side it's going to be 9, and on the other side it's going to be 12. This is a perfect triangle, and it's a ratio of 3, 4, and 5. So basically we should have a line going up and down right here to point C, and that should be 9 units, and we should have another one going from A to C, and that should be 12 units. Now that is if it's a perfect right angle triangle, which is what we are making right there. So that's what you want to do when we have a diagonal line, is you want to form a right angle triangle. Now let's figure out this bottom line, the line going from A to C. So remember to figure out the distance of that line. So we're looking at line segment AC. That's going to equal the absolute value of x1 and x2 of x2 minus x1. So x2 is 7 minus x1 is going to be -5, and that's going to equal 12, which is true. And then on the other side, the length BC, the line segment BC, is going to equal the absolute value of y2, which is 6, minus y1, which is -3, and that equals 9. So following the principles of the perfect triangle at 3, 4, 5, which has the similar ratios of 9, 12, 15, we've sort of proven that this is true right here. But remember, we're going to be able to punch this into the Pythagorean's theorem. And remember that this side right here is going to be side C. So basically we want to put it into this formula. C equals the square root of a squared plus b squared. So remember, any one of these can be A and any one of them could be B. So if I make the 9 into an A and the 12 into a B, I get C equals the square root of 9 squared plus 12 squared. And C equals the square root of 81 plus 144. And again, C equals the square root of 225, and if you punch that into the calculator, that equals 15. There we go. So we've proven it using Pythagorean's theorem and relating it to this perfect triangle that I showed you right at the beginning. So there is this distance formula right here, which is just a modification of what I just did there, the Pythagorean's theorem. So basically we've got the distance, that would be the length of C. So this one right here is the same as the C on the Pythagorean's theorem. And this part right here, x2 minus x1 squared, that is going to be our a squared. And the y2 minus y1 squared, that is going to be our b squared. Okay, so let's take a look at class example number 1. Now the first thing you should get in the habit of doing is labeling these points. So we just got to choose one of them as 0.1 and one of them as 0.2. So it makes sense logically just to call P 0.1. So this would be my x1 and my y1, and this would be my x2 and my y2. Okay, so now all we need to do is take that modified form of the Pythagorean's theorem and substitute the values into the correct spot and basically punch that into the calculator as you see it. So the distance of this diagonal line is going to equal the square root of x2 minus x1 squared plus y2 minus y1 squared. So I have those 4 points, so the distance is going to be the square root of x2 is 10 minus x1, which is 2 squared, plus bracket y2, which is negative 3, minus y1, which is 3, and that's going to be squared. Now if I continue with this, I'm going to get that the distance equals the square root of 8 squared plus 6 squared, and really what we have is negative 6 squared. Remember, we can take the absolute value of that, but if I put that into brackets like that, then it will turn out right if I put to punch it in the calculator. If I omit those brackets, we're going to have some problems. Okay, and basically we've got the distance equals the square root of 64 plus 36, and the distance equals the square root of 100. And in this case, the square root of 100 is 10. I just opened this calc app right here, and I just wanted to punch this into the calculator, and you should do the same thing right now just to make sure that you know how to do it properly. Basically what I want to do is punch in this line right here exactly as I see it. Okay, so this is going to be the square root of bracket 10 minus, so don't forget this is the minus over here, 2, close the bracket, square, plus, open another bracket. Now negative is not the minus sign, it's this one down here, so negative 3 and then minus 3, close the bracket, square it, and you can see that we get a value of 10. Okay, so I'm just going to take this and make it a little bit smaller so we can work on part B. All right, so part B, we're going to start off the same way. X1, Y1, X2, and Y2. And we're just going to put that into our formula, which is going to be bracket, bracket. I'm going to add those together. We're going to square what's in there. We're going to square what's inside of there. And we're going to subtract these two right here. And it's x2, which is negative 17. And that's going to be minus negative 25. And on the second one, the y is going to be negative 5 minus 3. Okay, now if we're to punch this into our calculator, let me just set up the screen here again. Okay, so I punch that in and you can see we end up with a value of 11.3. Now, unfortunately, that's not an exact value. That is going to be a rounded value. And if I look at the details right here, you can see here are the first 100 digits. So it's a non-terminating, non-repeating decimal. So this is just not equal to 11.3. It's approximately equal to 11.3. So what if we want to be able to give an exact value? Well, then what we need to do is lay this thing out and work it right down to the point where we can leave it in its radical form. Okay, so if I look at what we've got here, this is going to end up being 8 squared right here, and plus, you can see I've got a negative 8 squared. Okay, and if we now do the math, that's going to equal the square root of 64 plus 64, which is the square root of 128. And now what I need to do is look for perfect squares to pull out of there. Okay, well, I can pull out a 64 and a 2. Okay, so this can be broken down into root 64 and root 2. Okay, and as you know, root 64 is a perfect square, which is 8, but root 2 cannot be simplified anymore. So the exact answer would be 8 root 2. Okay, class example 2, we're moving on to a word problem, and there's just a lot of words there. So let's break this thing down. I like using my highlighter with different colors to pull out the important information. So sometimes grids are superimposed on maps and to find the distance between two locations. So for example, to calculate the distance between two craters. Now it doesn't really matter if they're craters. One's called Copernicus and the other one's called Plato, and who really cares? Okay, so basically we have a Cartesian coordinate system, and we've got 2 points, 2 random points, Copernicus and Plato, somewhere on there, and we're trying to find the distance between those two, and to do so we will end up making a right angle triangle and using Pythagorean's theorem. So again, let's try and see what important information we can pull out of this. So I'll just delete that really quickly. Ordered pairs, so that's what we really need. So it says that we've got one of them at negative 89 and 226. Well, we'll call that x1 and y1. And does it say which one that is? Okay, this is Copernicus. That's how you pronounce it. And what about this Plato right here? It is at 136 and 179. And again, this would be my x2 and y2. So out of all that written information there, this is all that is really important. But it's nice to look at the end and say, well, what are they actually wanting us to calculate? Calculate the distance between the two craters to the nearest unit. So in this case, it's not asking for an exact answer. It's just saying to the nearest unit, which means it's going to be rounded. And to the nearest unit means there are no decimal places. So again, we just take our distance formula, our modified distance formula, and we're going to do that, and we're going to do that, and we're going to take x2, which is 136, minus x1, which is minus negative 89 squared, plus y2, which is 179, minus y1, which is 226. And now we should be able to just round this into the calculator and come up with an answer. So the square root of bracket 136 minus negative 89 bracket squared plus open the bracket 179 minus 226, close the bracket, square that, and it's telling us the answer is 229.9. So the distance is 229.9 units. If it gave us actual units in there, we would use the units that were given, but it doesn't. And it says to round it to the nearest unit, which is going to be 230 units. And of course, if required, you would answer a word problem with a word answer. So the distance between the two craters is 230 units. Okay, moving on to class example number 3, the last one before the assignment. It says, Part A, explain how we can determine if a triangle is right-angled if we know the length of each side. So them saying each side is going to be important there. Okay, so each, whoops, that's not the function I was looking for. That's the function. So essentially, if we have a right-angled triangle, we know we've got side A and side B and side C. So what do we know? Well, the C squared is going to equal A squared plus B squared. So all you need to do is just take the value of C. So for example, if this was a perfect triangle, a 3, 4, 5 triangle, I would just put the 5 right there, squared, equals the 3 squared plus the 4 squared, plus the 4 squared, and I just see if that is true. Okay, well, what is 5 squared? Well, that is 25. And does that equal 3 squared, which is 9? 9 plus 4 squared, which is 16. Well, yeah, 25 equals 9 plus 16, which is 25. And in this case, we know it's true. So just take those known values, plug them into the formula. And remember, we're looking here at this equal sign. Whatever's on the left needs to be the same as whatever's on the right. Okay, let's take a look at question B, and I did a little bit of setup here just to speed the process up. So basically we've got 3 points, L, M, and N, and they give us the coordinates to those points. And I just drew a Cartesian coordinate system right here and labeled the points. And then I put the 2 points that create the line segments together here and labeled them as x1, y1, x2, and y2. So the question is saying prove that these 3 line segments create a right-angled triangle. So what do we know about a right-angled triangle? Well, C squared equals A squared plus B squared. So I'm just calling one of these, for example, C, and one of them A, and one of them B. So we got to figure out the length of that line segment between those 2 points. So we'll start off with this LN right here. And basically the distance of LN is going to equal the square root of x2 minus x1, which is -7 minus 0 squared, plus y2, 0 minus y1 all squared, which is going to equal the square root of -7 squared plus -1 squared, which equals the square root of 49 plus 1, which equals the square root of 50. So the square root of 50, we can leave it in that form right now as an exact value, and we're going to need to do the same thing to the other 2. Okay, so let's take a look at what we're calling A, line segment LM. And we're going to say the distance of LM is going to equal, again, the square root of x2, which happens to be -3 minus x1 squared plus y2 negative 3 minus y1 squared, which is going to equal the square root of negative 3 squared plus negative 4 squared, which equals the square root of 9 plus 16, which equals the square root of 25, which equals 5. Okay, and we will minimize this one and complete the work for the final one. Alright, so we've got the distance of nm is going to equal the square root, again, of x2, which is going to be negative 3 minus x1, which is going to be minus negative 7, squared plus y2, which is negative 3 minus y1, which is 0, and that's going to equal the square root of, well, remember that negative negative becomes positive, so negative 3 plus 7 is going to be 4 squared, put that in brackets if you want to, plus negative 3 squared, don't forget the squared right there, which is going to equal 16 plus 9, which equals the square root of 25, which equals 5. And I'm just going to make this a little bit smaller so we have room to work. Put that up here. So if we go back to this fact right here, which is the same as c squared equals a squared plus b squared right here. Let's grab this and move it down. And what do we see? What is c squared? That's ln. That is going to be right here. Root 50 equals, and that's going to be squared, equals 5 squared plus 5 squared. Root 50 squared, well, the squared cancels the root, and if you punch that in the calculator, you will see that that equals 50. And that equals 5 squared, which is 25, plus 5 squared, which is 25, and 50 equals 50. Therefore, we know it is a perfect right angle triangle because the left side equals the right side. And there we go. That should be enough to complete the assignment questions, numbers 1 through 12.